right, let's start talking about the spell work. Number 1 says factor and solve. When I see factor, first thing I always have to look for before I even think about drawing the X or the box. It does not have a GCF. We always have to check for it, but this one does not have a GCF. Good call. So once I know that, I can draw my area model, and I can make my X. What do I put up here? I put my A value, 3x squared. What goes down here? C, which is what? 4. Good job. That's all I can fill in the box by itself before I do the X. The X, I do A times C, so I do the 3 times 4, and that gives me what? 12. What goes down on the bottom? 7. My B value. Yes, has to multiply to the 12, add to the 7. So 4 and 3 is absolutely correct. These two numbers right here, I'm going to do that in a slightly different color. When I put them back inside the box, you have to put an X with them because those two together have to add up to 7x. It has to add up to my B term. Remember, that area model is my original polynomial. Then we look at only 2 boxes at a time, and we're going to pull the GCFs out of those. So let's look at just the top 2. 3x squared and 3x. What's the biggest thing I could take out of both of those?
3.
I can take a 3 out. Anything else?
X.
An X. All right, now let's look at just the bottom. 4x and 4. What can I take out of both of those?
4.
Only a 4. Positive 4 or negative 4?
Positive.
Positive. How do you know?
Whatever the body's touching.
Yep, whatever it's touching. Here's one of my factors. It said we're going to factor and solve. So that means I will take my factors and do what with them? Equal it to 0. So 3x plus 4 is going to be set equal to 0. I'll solve it in a minute. I want to get my other factor first. I still need to get the top of the box. We did up and down, so now we're going to do left and right. On the left side, what's the biggest thing I could take out of 3x squared and 4x? 1x. And now the last one. Just 1. And you said positive? Yes. The only thing that goes into 3 and 4 at the same time is 1. The box that it's touching is positive, so this is also positive. So that's the other thing that I'm going to set equal to 1. Or sorry, set equal to 0. Ugh. Okay, we've got 2 equations to solve from here. 3x plus 4 equals 0. What do I do first? Yep, minus 4 from each side. So I get 3x equals negative 4. Divide 3 on each side. So one of my solutions, one of my x-intercepts is what? Negative 4 over 3. There's one final answer. What about the other one? Subtract 1 from each side, and that means the other x-intercept, the other solution is negative 1. Beautiful. All right. That finishes off problem number 1. Let's go look at problem number 2. Remember, I told you that this inequality right here, we don't need this to do the problem. This is our domain restriction. This is here so that our answer is a function, would pass the vertical line test. But once I know what that restriction is, I don't have to do anything with it for the whole rest of the problem. What does inverse mean? Not opposite, but close. To switch. It's going to undo things, so it's kind of like an opposite, but I don't want to get it confused with like always subtracting or always being negative. First thing I always need to do when I'm finding an inverse, change it to a y equals. We want to get rid of our function notation here. And then we're going to switch our x and our y. That's our step 2 there. So instead of a y at the beginning, I'm going to have an x. Then I'm going to recopy my equals sign. When I switch the x and the y, the only thing that moves or changes is just those 2 letters. Everything else is 100% identical. So what do I see after the equal sign? 3y squared plus 10. Beautiful. Once we've switched those 2, this is an inverse. It's not written properly. To be written properly, we need the y by itself, but this is an inverse. Just doing this much on the test is worth points, because that's a super important concept here when we're talking about inverses. Now I want to work on getting that y all by itself. Subtract 10 from each side. I'm going to write down our order of operations off to the side over here. Yes, because we're trying to isolate the y. That's what it means to get something alone. So we start down at the bottom of order of operations. I'm looking for any addition or subtraction on the same side where the y is. We see that plus 10. I need it to go away. So we're going to subtract 10 from both sides to make it go away. So minus 10, minus 10. Yes. X minus 10 equals 3y squared. I want to point something out very quickly. I haven't seen it happen very much this year, so this is awesome. X minus 10, I would not write negative 10x down here. Negative 10x is saying multiplying, and we said we're subtracting. Make sure that whatever you write down when you put things together, it's using the same operations that you said you were doing above. So if it's a minus here, it should be a minus there. Is there any other addition or subtraction on the same side as y? No. So we did that step. So addition and subtraction we are done with. So then we hop up here to multiplication and division. Yes. 3 is being multiplied to that y squared. I'm going to have to bring my work around here. So x minus 10 equals 3y squared. We need to divide by 3. And if I do it to one side, x and negative 10. I can do it all at once like this with one big fraction bar, or you can do it to each one separately. But it has to happen to everybody over there. I don't care whether it's one big fraction or whether you do it to each one separately. So that's going to cancel. So that gives me x minus 10 over 3 equals y squared. Is there any other multiplication or division over on the side where y is? Nope. So we're done with this step. Are there any exponents? Yes. There's a squared. What will undo something that's been squared? A radical. Specifically, it is a square root. Square roots. Roots undo exponents. So if what I see is a square root will undo it. If what I see is a cube, then a cubed root will undo it. Whatever my exponent is, that's what the index on my radical would need to be to undo it. So we're going to take a square root of both sides. If I do it to one side, so like this, has to be the entire thing over here. The whole fraction, top, bottom, all the way over that minus 10. What happens right here? Y becomes by itself. The squared and the square root cancel each other out. And I have this enormous square root sign with x minus 10 over 3 underneath it equals y. You guys okay with that so far? Okay. Is y by itself?
No. Oh, well, yeah.
Yes, y is all by itself. I'm happy about that. That means I got to the end of step 3. Very last thing I need to do so that anyone and everyone who looks at this knows that that is the inverse for this right here. Yes, we have to name it. We're going to look at our original function to figure out what the name should be. If this is f of x, f inverse of x. So I have an f with that little -1 and then an x equals, and that takes the place of the y over here. So I don't need a y in this anymore. Big, gigantic square root sign. What goes underneath it? X minus 10 over 3. Yep, no index. If you wanted to write it, you could. It would be a little 2, but for square roots, we don't have to write the index. That would be our final answer. Awesome sauce. Let's do the last one on the belt work, and then we'll go back to what we were working on yesterday with the inverses. Tamika is riding her bike. Her distance from her school is represented by this function right here. What do these bars mean?
Absolute value.
Absolute value. What does absolute value mean?
How far away from 0?
How far away from 0?
It can be negative or positive.
Can be negative or positive. What do these two variables mean? What does the letter D mean? Distance and time. They ask a when question here. If somebody asks you a when question, what do they want to know? Time. So we're going to find t. What is that 10? Distance. So I'm going to take that 10 and put it in the place of the letter D. So it's going to be 10 equals 2, and then absolute value of 60 minus 4t. What's the first thing I want to do right here?
Don't you make it into 2 like?
We will do that in just a moment. We need to divide by 2 first, because I have to isolate this absolute value before I split it up, because right now the distance is not alone. I need my distance to be alone first. So we're going to divide both sides by 2. You cannot distribute it because absolute value is not parentheses. When I divide by 2, all it does over there on the right is get rid of this 2. It cannot touch anything inside here. 10 divided by 2, I get 5. Yes. So here's my number line. Here's 0. What is our distance? 5. Yep, -5 or +5. Those are the 2 possible locations where the part inside the absolute value could possibly be living. So 60 minus 4t could be over here at -5. Or 60 minus 4t could be over here at +5. And we have to solve both of those. I don't have a whole lot of room to work with there, so I'm going to swing it around and do it over here. 60 minus 4t equals -5. I would start this by subtracting 60 from both sides. -4t equals -65. Then I'm going to divide both sides by -4. That will make it positive. And that's really good because t means what again? Time.
Time can be negative.
Time can't be negative. I got to have a positive. So I'm really glad that we're doing negative divided by negative because that means I'm going to get a positive answer. Grab a calculator for me. -65, 16.25. What kind of units should we put on that? Seconds. They didn't tell me in the problem, but she's riding her bike and she's only 10 feet away. That's probably seconds. So there's one answer. We still have to find the other one. 60 minus 4t equals positive 5. So I'm going to subtract 60 from both sides again. Does that give me a positive 65? No. What does it give me? Negative 55. And then divide both sides by negative 4. When is the other time that she's 10 feet away? 13.75. And we'll put seconds with that as well. Fantastic, beautiful work, guys. Let's go back to page 214, which is where we left off yesterday. Back to page 214. We did part B together yesterday. We're going to do part A. You guys are going to do part C. First thing I need to do. What's the first thing I need to do?
Do the y.
Do the y thing. That f of x is going to become a y. Because I can't switch x and y if I don't have a y. Yes, then we're going to switch. We're going to have x equals y squared minus 4. Yep.
Add 4 to both sides.
Yes. We're going to isolate y now. So we're going to add 4 to both sides.
We have x plus 4 equals y squared.
You beat me to it.
Square root.
X plus 4 equals y squared. And Soraya said square root, right? So like that?
No,
All the way over. Has to cover the 4 too, because the rules of algebra say if you do it to one side, you do it to everything on the other side. Got to be the whole thing. What happens on the right?
the exponent cancels out, so you have equals y.
Yep. So I have the square root of x plus 4. Make sure that the roof of that square root comes all the way over. Equals y.
And then you do your inverse.
And then we do the inverse. This right here was all of step 3. What should my name be on this one?
F inverse of x.
F inverse of x equals what?
Square root, and then you put the x in plus 400.
Yep. And that's my final answer. Part C, yes.
I have a question. So on the second one over here, the simple y, is that how we do this? Because you see it has an x over 9, and then 4 is the square root of 2, so.
It is. The only thing that throws us off there is this plus sign right here. If it was multiplication instead of addition, like if that was 4x, then we could do the square root of 4 and take out a 2. But that plus sign, if you see pluses and minuses, we can't do anything with that with radicals. So if there's pluses and minuses under the radical, even if pieces are perfect squares, we can't touch them. That was a great observation. Part C in your books is almost 100% identical to the bell work problem that we did together. I want you guys to practice part C on your own. Flip back and forth to the bell work. Same exact process, just different numbers. I'm going to give you guys about 2 minutes to do that one on your own, and we'll check back in together. Practice this one for me. You need to work on this one for me, too. Yeah, now I saw that up. Oh, I'm sorry. Yes. You doing okay?
She's bullying me.
Hmm?
She's bullying me.
I know, she picks on you all the time. Okay, so I've started working on it up here. I remembered to do my replacing so that I had a y. I did my switching. So now instead of a y equals, I have an x equals. I subtracted my 12 from both sides. But now I'm stuck. What do I do next?
You need to divide 5 from each side.
We need to divide the 5 from each side. We got done with this step. So I'm right here. Divide by 5 here. What do we want on the other side?
We divide the whole thing by 5.
Yeah, divide the whole thing by 5. Would it be okay for me to do it like this?
Yeah.
Yes. Is that the only way? What else could I do?
We do the whole thing.
I could do the whole thing. Gigantic fraction bar with a 5. I don't care which way you do it. Whatever's easier for you. All right, so I have x minus 12 over 5 equals y squared.
Square root on both.
Square root on both over the whole freaking thing here. What happens on the right?
The square thing we cancel out, and then it's just a y.
We're going to have just the y over there.
And then you bring that whole thing down.
Bring that whole thing down. X minus 12 all over 5. This whole piece of work here was my step 3. Switch. Switch what?
You make the y back into the t, but you do the inverse. So
Yes.
it's t inverse of x.
Equals what?
Radical x minus 12 divided by 5.
Love it. And I'm done. Okay, there should be colored pencils out on most of the tables. If you don't have a box of colored pencils, there should be one somewhere near you. Grab 1 or 2 colors. Thank you. If you have colors of your own, you're welcome to use your own colors. And after you guys have all picked out colors, go ahead and pass it over here because I didn't have quite enough boxes for everywhere. Grab 1 or 2 colors. I'd probably steer clear of yellow. It's hard to see on your page. All right. Do you guys remember back in Unit 3 doing compositions of functions where we took one function and we stuffed it inside the other function? We're going to learn how to do that with these inverses now. How will I know if they really are inverses? Yeah, we're going to put them together, and what am I looking for to happen? What do I want my end result to be for me to say, yep, they're inverses? Not a 0, but just an x. X all by itself. If I get just x, then the functions are inverses. When we do our composition to check to see if things are inverses, do we have to do both directions? Do I have to take g and stuff it inside of x and then take f and stuff it inside? You only have to do one, because if it comes out to x one way, it's going to come out to just x the other way. If it doesn't come out to x one way, then it won't come out to just x the other way. All right, if you've got two colors, use one color for f and one color for g. If you only picked out one color, use your regular pencil for one of them and your color for the other one. I'm going to do f of x in blue, and I'm going to do g of x in red. Even though we know we don't have to do both directions, because these are quadratics and roots, I'm going to demonstrate both directions so that you guys can decide which one you think is easier when you do it on your own on your homework, okay? So I'm going to take function f, and we're going to stuff g of x inside it. What is that function g of x? That's my f. What's my g?
Oh, radical x plus 3.
Radical x plus 3. That is what's going to go inside my function f. So now I'm looking at the function f. Yes, ma'am?
Why? You know how when we did the last one, you would choose the fractions to be on the outside and not the inside? Is that kind of like this? You'd rather choose to do radicals on the inside?
I'm going to demonstrate both ways because on this one, I don't have a particular favorite. So I'm going to show you guys both directions, and you can decide which one you think is the easier one. Okay? I didn't touch the minus 3 yet. See, I still have the letter f here. I haven't written down any of this function yet. I just wrote down the g of x part. So far, so good? Okay. Now I'm going to start copying down my function f. So right after the equal sign on the function f, what's the first symbol you see? Parentheses. So I need parentheses. After the parentheses, we see what? X. I'm not going to write down x, though. This is where my substitution goes. I'm going to put this instead. So that's where I put the radical x plus 3. That takes the place of this letter x right here. Then we do minus 3 after that, because that's part of my function f. What comes after the minus 3 here? Parentheses and squared. Beautiful. Do you guys see my function g in here? And all the other pieces around that came from my function f. The only thing that I didn't write down from this function was what letter? The x right here. Look inside these parentheses here. Order of operations. We're not solving for anything. We're not isolating. We're just simplifying. Do you see anything that will simplify in here? Plus 3 minus 3. What happens? They cancel each other out. Yep. So I have a radical x left inside there. What's on the outside of my parentheses still? Squared. Wait a second. What do we know about squares and square roots? They cancel each other. Yes. I can't cancel them up here because as long as I have pluses and minuses, I can't do that. But since these canceled each other out, and I was left with just this, then I could see that I have only x left. So, yes, they are inverses. Only x left when simplified. Yay! All right. If you're doing your homework, I only have to see one direction like this. I'm going to show you the other direction so that we have experience with doing it the other way, because you might like the other way better. Yes, sir.
Why did you not the other x?
What'd you say, dear?
Why did you not the other x?
Why did we not write the x? Because when we do a composition, we're going to make a substitution in the place of x with whatever that other function is. Does that make sense? Okay. So I have my function g on the outside, and this time we're going to stuff f inside it. So I still have my letter g on the outside. What is that function f again?
Does that mean it's gonna go under the whole square root?
I'm sorry, one more time.
It's gonna go under all the square root?
Yes, it is.
It's x minus 3.
Yep, inside parentheses, x minus 3, and it has a squared on it, right? Okay. Right after the equal sign in my function g,
Radical x.
radical. I need a radical.
You substitute the x.
Yes. Instead of writing this letter x, that's where my substitution goes. I'm going to put all of this stuff in blue underneath the radical instead of writing the letter x. So I need the parentheses. I need the x minus 3, close it, and squared. Do I need anything else?
Plus 3.
Plus 3.
But that's not under the radical.
It is not under the radical, so I'm not even going to worry about it right now. It needs to be written down, but I'm not dealing with it yet. That x minus 3 is inside parentheses, right? It's all contained in there. What's outside those parentheses?
Square.
A squared.
But it's under a radical, so they cancel.
They're going to cancel each other out. This cancels with this. So I have just the x minus 3 left right there. I don't need the parentheses around them anymore because there's nothing else there except for this guy who was never underneath the radical to begin with.
But then you do -3 plus 3 is x. So.
Negative 3 plus 3 cancels out, and I'm left with only x. So no matter which way we did it, we got just x left. Beautiful work. Absolutely beautiful work. You guys can decide which way you think is easier on a particular problem. I don't care. I only need to see one direction. All right, I'm going to ask you guys to flip forward several pages for me now. We're going to go to 241. 241. Thank you, Gina. Page 241. Ugh. That's really dark. Sorry. Can you guys see this okay? This is at the very bottom of 241. Can you guys find that on your page? Way down at the bottom of 241. They have some things here that are set up like compositions, right? What's inside these parentheses, though?
X values.
X values, not x's, but numbers, right? So we're going to do a composition, but we're going to be sticking numbers in here.
So will we ampersand and then stick the composition?
Let me demonstrate what we're going to do. All right? This first one, what's my outside function? F. So I have an F right here. Inside function is which one? G. What do they want me to use in the place of x? 3. Put in for x. So in my function g, which is the square root of x minus 1, I'm going to put 3 in the place of the x there. So far, so good? Okay. What's 3 minus 1? 2. So I have square root of 2 right here. It's not, unfortunately. The square root of 1 is 1. The square root of 2, Yeah. I'm not worried about what it is. I'm just going to leave it like that because you're right, it is a decimal. It's gross and messy. So I'm leaving it like this right here. This is what we're going to put into our function f. So what is my function f? What comes after the equal sign in my function f? X squared. Instead of writing the letter x to be squared, what are we going to do?
2.
Not just 2, but
2 squared, I mean,
radical 2. And then I see minus 3, and then there's another x, so I'm going to do another substitution. Radical 2. I need to drop this down because I'm running out of room. What comes at the very end? Plus 2. And now we're going to see how much we can do to clean this up. I'm going to move this down here also. Can this simplify at all? That cancels out. Cool. Squared and square root are no more. So that just leaves me a 2 right there, right? Minus 3. What's going on between the 3 and the parentheses? They're being multiplied. Can I simplify this at all?
No.
Not really. The only thing I can do is write it like this. That's still showing multiplication.
So it comes negative 1.
Nope. Just stays like that. This part right here doesn't simplify any more than that.
Where did 2 go?
This part?
Yeah.
I didn't bring it down yet. Good question. So we're going to bring that guy down. Can I do anything else to simplify this? What? Can't do the 2 minus 3 because it's being multiplied. I would like to.
You do 2 plus 2.
I can do 2 plus 2. What's 2 plus 2? 4 minus 3 square root of 2. That's as much as I can do with it. For any of the composition problems, if they want to know, are they inverses? That's where you take it and stuff it inside. If they give you a number, you're going to put that number into the inside one and then evaluate. All right. Guys, homework 3 is due on Monday. That's practice with compositions. Please send me lots of messages over the weekend for anything you're confused on. Send me messages in Canvas if you are confused or lost on any parts of the homework.